Okay, so as a tutorial here, I'm going to help you guys out. This is the first problem from lesson number 1 of the week. It says, in a railroad yard, a train is being assembled. An empty boxcar coasting at 3 meters per second strikes a loaded car that is stationary, and the cars coupled together. Each of the boxcars has a mass of 9,000 kilograms when empty, and the loaded car contains 55 kilograms of lumber. For me, especially when I first started doing these problems, it always helped if I made a drawing first. So here's my empty boxcar moving at 3 meters per second, running into my stationary boxcar that's loaded with the lumber. And then after they collide, they're going to move together as one thing at some new speed. So first part says complete the momentum conservation diagram. So it doesn't matter how many bars necessary that you give each one for their momentum, as long as you're able to keep it going and make it so that the beginning and the end add up to be the same thing. So at the beginning, I've got my empty car moving. I just gave it a random 3 bars of momentum. You could have made it whatever you wanted, but I also have it moving in a positive direction. What that means is at the end, the momentums have to add up to 3 bars also. So again, at the beginning, there's only one car moving. That's my empty car, so that one's got momentum. The loaded car has 0 momentum because it's stationary. At the end, the 2 are moving as one thing with the same amount of momentum. For the momentum conservation equation, your initial momentum has to be equal to your final. Well, at the beginning, I've got 2 separate objects moving at 2 separate speeds. At the end, I've got the 2 objects moving as one thing, moving at one final speed. And then at the end, when we're asked to find the speed, I'm going to go ahead and rearrange that equation that I had before. So from m1v1 plus m2v2 equals m1 plus m2 times their final velocity. I rearrange that to come up with this equation. m1v1 plus m2v2 over the quantity of the 2 masses combined. Now, to find the speed of the coupled boxcars, again, I've got my formula. I plug in my values. So mass 1 was 9,000 moving at 3. Mass 2 was 9,000 plus the lumber moving at 0. And then at the end, the total mass are my 2 cars plus the lumber. So I'll get this value, okay? Again, for momentum, the units are just what we see. It's kilograms times meters per second, okay? And then again, the mass down at the bottom, kilograms. I do math, I get a value, 0.3699 meters per second, or we can round it to 0.37 meters per second. So this is just an overview of the basic setup on how to go through these problems. If there's any one that you guys are working through that you want me to do and post a video for, just hit me up in email or let me know during our Zoom meeting, and I'll go ahead and set it up on whiteboard and load it for you guys. So with that, hope everything's going well. Hope you guys are feeling good and continue with your learning. I appreciate you guys hanging in there. All right.